Okay, so welcome to this episode of How Do We Pass Our Common Core Algebra Regents. So what we're going to do today is we're going to start actually with the big guns. So we are going to solve system of linear equations, okay, by graphing. Now, what is it to have a system of the solution to a system of equations? The solution is where the two lines meet, basically, where the two lines intersect. All right, where the two lines have the same order pair in common. So we're gonna do this graphing and with the calculator. So let's start with this. Notice that these equations are solved for y, but once again, the equations need to be solved for y if you're gonna be graphing. Otherwise, you cannot do it. So let's try it. Let me see. I'm gonna start using this. The first one. The slope of the first one is negative 3 over 1. All right. So yes, we might want to actually write it down. Negative 3 over 1. Okay. And the y-intercept is 4. Okay. So that means that I'm going to start at 0, 4. And I'm going to work my way up or down to according to the slope. The slope is negative 3 over 1. So I cannot go up 3. But it's negative 3 over 1, Becker. What the hell? Why the hell you want to go up? Oh, you're right. 3 down and 1 to the right. Okay. So 1, 2, 3, 1 to the right. 1, 2, 3, 1 to the right. I don't need to graph anymore. But let me just do it, okay? So I graph this one. And now, these are equations, not inequalities, so the lines are going to be solid. So look at that. Okay. Boom. Boom. All right. Now, the next equation. The next one has a slope of 3 over 1, okay, and a y-intercept of negative 2. The sign is very important. So negative 2. So I'm going to try to see if I can do it in a different color, although I don't want to go through the paper because we have things on the other side of the paper. Okay. Where is this thing? All right, I use this color. So I'm gonna start at negative 2. Okay, and then I'm gonna work my way up to according to the slope. 3 up and 1 to the right. So 1, 2, 3, and look, 1 to the right. 1, 2, 3, 1 to the right. And I have my line. Up 3, down 1, or down 3 and to the left 1. Really doesn't matter. So why do I keep on? So you see that? And now we graph our straight line. Alrighty. And now the point where the lines intersect is your solution set. So your solution set for this one is going to be the point 1, 1. And that's basically how you graph a system of linear equations. Let's try another one for size. Let me see now. This is number 2. Okay, number 2 is going to be fun. What do I know? Well, let's take a look at it. Identify the slope and the y-intercept. So we know that the slope here is 1. And the y-intercept is 2. Okay, so now I'm going to go to the y-intercept, which is 2. And now I'm going to move according to the slope. The slope is 1, so that means that is 1 over 1. 1 up, 1 to the right. Or if not, then 1 down, 1 to the left. Still having the same behavior. See that? And now graph my ruler. Alrighty, look at that. And trace your line. You trace your line. Now let's take a look at the other one. The other one, it says x equal to negative 3. Wait, x equals negative 3. It has no slope. The slope is undefined. How do I know that? Because this is a command that says graph x equal negative 3. Let me see, if y is any value, x is still going to be negative 3. So I go on to where x is negative 3. Okay, and once again, we did this before, but I'm still doing it. So I'm going to graph negative 3, 0. Okay, if y is 1, x is still negative 3. So look, vertical line all the way. Got it? And now we trace our vertical line. Gosh, This thing is too far for me. Oh, okay. And now with the point of intersection, which is the same point for this line and the same point for this line, is your solution set. So now your solution set is going to be -3, -1. Solution. And please, yes, write solution. And always remember to label your lines. I'm not going to be labeling lines, but this is x equals -3, and this is y equals x plus 2. All right? Cool then. Let's take a look at number 3. Number 3, a little bit difficult. Yes, why? Because it's not solved for y, so I'm going to solve for y. So let me grab a piece of paper. I don't have no more paper, Becca. Oh, duty. So, the equations were not solved for y. It don't matter. We're going to solve them for y. Hopefully you can still see. Alright, x minus y equal 3. I'm going to show you a secret, and if you don't grasp it, then we go back to basics. So look, you're supposed to solve for y. The idea is to leave the y by itself. So if I was to solve for y here, I would definitely get rid of the loose number, which I already did, or it already automatically did. And then I'm going to get rid of the x term. So I subtract x from both sides. Okay, I get -y equals, and of course 3 minus x, you cannot do it because they're not like terms. So you just write -x plus 3. And now the y is negative. You cannot have a -y as a solution or as an answer or as an equation solved for y. So what you're going to do is you're going to multiply by -1 and you're going to distribute that. So that's always the case. So multiply by -1. So now what happens? The -y becomes positive, but then the -x also becomes positive, and the +3 becomes negative. So now you have it. Y equals x minus 3. So let's have the same equation, and I'm going to show you what to do. Look, easy. In these cases, I know that's not what you're being taught, but anyways, get the y and put it on the other side. And get the 3 and switch places. So what I was taught was that if you have something negative on one side, it goes to the other side being positive. And if it's positive, it goes to the other side negative. So then by putting the y on the other side, it becomes positive. I put the equal sign. And now the x is still positive. I haven't done anything. The 3 that I switch places with the y becomes negative. Now you want to rewrite this? Sure. Y equals x minus 3. And you see, both of them give you the same answer. So now you know an extra trick. Alright, so I got one of my equations solved for y. But we still have the other one. So what is the other one? The other one is 7y. Okay, sorry, 7x. 7x minus y, right, equal -3. Sorry, that's what you have. That's the other equation. So then we're gonna solve for y. Once again, you could use this trick, or you could always solve for y the traditional way. So let's subtract 7x from both sides. So we get rid of it. Drop down the -y. Remember, you subtracted 7x, so that means that on this side you have -7x. The 3 is negative, so -3. You cannot have a y negative as an equation solved for y. So we're gonna multiply by -1. You already know what multiplying by -1 does. It changes the sign of everything you have. See that? And now your two equations. So now I'm gonna write the two equations that I have in here. So this one is y equals x minus 3, and the other one is y equals 7x plus 3. Okay, now we are going to graph them. Cool. The slope of this equation is 1, and the y-intercept is -3. So I'm going to go to -3, and I'm going to go 1 up, 1 to the right, 1 up, 1 to the right, 1 up, 1 to the right, 1 up, 1 to the right. All right, I'm going faster because we've been through this already. So now grab the ruler and do it. Okay, straight line, arrowheads, you label the equation y equals x minus 3. And now let's graph the other one. The other one is going to be the following. The y-intercept is 3. So I'm going to go to, why am I, this is, no, same color. Okay, here. 3. So we go to 3. And now the slope is 7 over 1. Meaning what? 7 up and 1 to the right. So, oops, cannot go 7 up and to the right. So easy, go down to the left. So 7 down, 1, 2, 3, 4, 5, 6, 7. Okay. Oh my God, this point does not exist. Okay, sorry. 7 down and 1 to the left. And I cannot go anymore. So this is your line. Usually on the regions, you're gonna get the graph paper is gonna look a lot better than this one. And it's gonna have more points. So these are your two lines. The point of intersection is the solution. So the solution here is -1, -4. So solution -1, -4, and you write solution. Now I'm gonna show you how to do it on the calculator. X minus 3. All right. So we look at the graph, what it looks like. You see that line? That's this line right here. And now we're gonna go, we could look at the table of values. You know how to do that. Second graph. And then you graph it if you don't want to use the slope intercept form. Now let's graph the other one. The other one was 7x, okay, plus 3. Beautiful. 7, okay, x plus 3. And graph. And boom, it looks exactly like this one. Actually, mine looks better. And point of intersection. So you could either trace the point of intersection or do the following. Press second, okay, second calculate, you see? Second calc. And you want to go to intersection point. You press enter. Now it's gonna ask you, first curve. When it says curve, means either a curve or a straight line, it doesn't matter. So yes, I want it on the first curve. What the second curve is gonna say? Yes, I want the intersection between the first curve and the second curve. Oh, you want me to guess the intersection? Oh my God, yeah, I want you to guess the intersection. So boom, and there you have it. Okay, look. When x is 1 and y is 4. Sorry, -1 and -4. Okay, and that's basically how you do this. Let me see, can I make you see this better? I don't know if you could see it. Anyways, so that's it. That's how you solve a system of equations by graphing. Now, we are going to solve a system of equations by something called elimination and substitution. For elimination, both equations must be in standard form. Both equations, plus or minus, I'm going to put plus or minus, okay? You cannot do it if the equations are in different form. If, for example, let's say you have the equation in this form, then you turn it into standard form. You already know how to solve equations for whatever you want. In other words, you gotta solve it for C, for the number. C is a regular number. C is a regular number. So you solve the equation for that. How do you do that? Well, what's bothering the C? The y. So subtract y from both sides, and you get x minus y equals C. And now it's in standard form. Got it? All right then, let's do some damage. Because I just told you what you needed to know, but we still don't have it. You wanna hear something funny? I don't know what I did with the paper that I had in here. Oh, okay. All right. So for example, the equation. Solve the system of equations by elimination. So we're gonna do that. Elimination. Let me just zoom out. Might be small, but okay. We're gonna use elimination method. So how do you do that? But let's have our first system. 8x minus 6y equals negative 20. And then we have the other equation, which is negative 16x, okay, plus 7y equaling 30. So, how do you solve a system of equations by elimination? Easy. First, you choose what you want to eliminate. So, for example, let's say I wanted to, we're gonna do this in two different ways, okay? So it's gonna be really hard. But once we're done, it's gonna be good. Let's say I want to eliminate the x variable, all right? Oh, by the way, if you solve this for y, both of them, you could just grab them and find the point of intersection of the lines. That's given. We did that already. But in the elimination method, we ask a couple of questions. You want to eliminate the x, but first ask the question. Are the equations in standard form? Yes, they are. Look, x plus or minus y equal to a number. Okay. And now you chose the x to be eliminated. So you're going to take your two values, okay? 8x and negative 16x. 8x and negative 16x. And you're going to ask yourself, how can I make these opposites? How can I do that? Well, easy. Multiply the 8 by 2. If you multiply the 8 by 2, what is it that you're going to have? You're going to have 16x. And the bottom one, you don't have to multiply by anything. It's already negative 16x. So now the opposites. Oh, exactly. That is how you do it. So now we multiply the top equation, the whole thing, okay? Not just one number, the whole thing, because you got to keep it balanced. The whole thing by 2. We just saw that. And we're going to write our two new equations here. So let's see now. Let's distribute property. Let's distribute this, so you get 16x, okay, minus 12y equaling negative 40. We'll multiply. We didn't do anything to the bottom one. Ah, no. Positive 30. Oh, okay. We're good with that, right? All right then. So let's move on. Now, after you make them opposites or additive inverses, if you want to use mathematical vocabulary, look, you just add them up. So 16x minus 16x cancels out. 0x, nothing. Then negative 12y plus 7y is negative 5y. And then on the other side, negative 40 plus 30 is negative 10. Now you divide by negative 5 on both sides and you get y equals 2. All right. Yes, but the solution to a system of equation has to be an ordered pair. X comma y. I found the y. So how am I going to find the x? Woo! Nah, just kidding. Take the value that you have for your y and substitute it into one of the original equations. Choose one, top or bottom. Okay, I don't know. I guess, yeah, I want to the bottom. Yeah, fine, let's do the bottom. So you rewrite the equation in the bottom. Let me use different ink. So you rewrite the equation in the bottom. Negative 16x, okay, plus 7y equal 30. And now you substitute the value that you found for y. So you got negative 16x plus 7 times y, 7 times 2. And that equals 30. Once again, you rewrite negative 16x plus 14. In the future, you don't have to do all this. In the future, if you can just calculate right away, then you do it. Okay, equaling 30. Now we solve for x. So we're going to subtract 14 from both sides. Okay. So we do minus 14, right? So you get negative 16x equals, okay, so what is 30 minus 14? 16. And now we divide by negative 16, and x is negative 1. All right, notice that I am trying to simplify because this thing can take up to a whole page. So now solution. So you write solution. Solution is 16 for x. No. Sorry. Negative 1 for x and 2 for y. Boom, solution. Now, what does this solution mean? Well, it can mean many things, and I'm going to explain to you right now. The first thing, algebraically, which is meaningless, it basically tells you where the lines intersect. In economics, okay, when you're talking about demand, supply, two companies competing one another, one giving a better price but charging more at the beginning, the other one charging less at the beginning but giving, I don't know, whatever, then this point will be where the two companies are making either the same amount of money, are losing the same amount of money, are at a break-even point. That means that the same, okay? Break-even point is like when you're not making money and when you're not losing money. But if you're not making money and you're not losing money, but you're not making money, you're losing money. You got it? Oh, okay. All right. Let's do another equation by elimination method. Oh no! Wait. I was showing you this. Here you decided to eliminate. Well, I decided to eliminate the x. But what if you don't want to eliminate the x? What if you have the two equations, right? So you have 8x minus 6y equaling negative 20, and the other equation is negative 16x, okay, plus 7y equaling 30. What if you didn't want to eliminate the x? What if you just wanted to eliminate the y? Well, same process. Take your two values for the y's, negative 6y and 7y. And ask yourself, how can I make these two quantities opposites? Well, if one of the numbers is a prime number like 7, the easiest thing to do is just multiply them by each other. So look, 7 times 6 is 42. So I get negative 42y on top. And then negative 6 times 7 is negative 42. But I need opposite. So without the negative, just multiply 6 times 7. That gives you positive 42. Why? So what did I do here? I multiply by 7, and here I multiply by positive 6. Otherwise, that would be the same number. Got you. So that's what I do to both. And I'm going to do it. It's going to take a long time, but hey. So the top equation gets multiplied by 7. The bottom equation gets multiplied by 6. Now, be careful and choose wisely. I'm gonna have to use the calculator here because I'm gonna get big numbers. So, and I'm serious. 7 times 8 is 56. So I get 56x. 7 times 6 is 42. So that's negative 42y. And 7 times 20 is 140. So this is negative 140 because. Don't mind me not multiplying the signs, okay, but I'm still doing it. Then the 140. Now, in the bottom, 6 times 16. Well, 6 times 10 is 60, 36. So that's negative 96. X plus 42 equaling 180. All right. So now, what is 56 minus 96? Minus 96. That's negative 40. So I have negative 40x. These two, they're going to cancel out. And now this is positive 40. Look, negative 140 plus 180. In other words, 180 minus 140, positive 40. Divide by negative 40 on both sides. And you get x being negative 1. And look, x is negative 1. To get the y, all you have to do is get this value for x and substitute it into one of the original equations. I'm not going to do that. I already showed you that it works both ways. All right. I'm going to do two more. This method is kind of like long, but it's worth it when you don't have graph paper and when you have to prove yourself. Okay, I'm gonna try to use the other side of this paper if it works. Alright, so the next example. So now choose what you want to eliminate. Alright? Choose wisely. And if you wanna go back to the previous couple of minutes, whatever, go back, okay? So you could see how it's done again if you forgot. In my case, I'm gonna eliminate y, because all I have to do is multiply this 5 by negative 2, and sorry, by positive 2. Even I make mistakes. You know what? Let us take the numbers over here. So I want to eliminate the y. So I have negative 10y and I have 5y. What do I need to make them opposites? Easy. Multiply the bottom by 2. Okay? If you multiply the bottom by 2, you're gonna get the top one. You don't need to do anything, so you get negative 10y, and the bottom one becomes 10y. That's why I chose to eliminate the y. If I had to eliminate the x, I would have to, let me show you what I would have done to eliminate the x. So you have a negative 8x and you have a positive 6x. So all you have to do is find a common multiple of this. Pretend that they were denominators, and where would they meet in the times tables? Well, they meet at 24. So I'm back. So if you wanted to eliminate the x, you will have to turn them into something. I know they have in common 24, so I will multiply this by 3 and this by 4. Okay, to make this negative 24 and this positive 24. You get it? But anyways, making this, multiplying by 2 and making this a 10 is the easiest thing to do. So let us go back over here. So I'm going to multiply by 2 and I'm going to rewrite my two new equations. Okay? So let's see. Let me rewrite them. What's having? Yes. Alright, I didn't do anything to the top one, so negative 8x minus 10y equaling 24. And now, okay, to the bottom one, let's see the change. So I'm just multiplying by positive 2, remember? Positive 2. So this is 12x. This one becomes 10y, so plus 10y. And this one becomes 4. See, that's why it was easy. Oh, okay, now let's just add them up. So negative 8 plus 12 is 4. So that's 4x. These two cancel out because they're opposites. And then this is 28. Now divide by 4 and x becomes 7. Okay, and now to find the y, easy. To find the y, all you have to do is substitute. So let's substitute. Substitute on the original one. Choose top or bottom. You choose one. I'm gonna choose the one of my choice and do it. Okay, so I'm gonna choose the top one. So what do? I rewrite the equation, so it's negative 8x minus 10y equal 24. Now replace the x. So it's negative 8 times the value of x, which is 7, minus 10y equal 24. 8 times 7 is 56, so this is negative 56 minus 10y equal 24. I'm going to add 56 to both sides, right? So you get negative 10y equals to 80. Divide by negative 10, and y is negative 8. Solution is 7 comma negative 8. All right. Woo! This was the system of elimination, and I'm gonna show you one more, and that's it. Because I gotta show you the other method. Let's see. Choose one that it's nice. Okay. This one is going to be OD difficult, but nothing better than try a challenge. So I'm going to have negative 24, all right, minus 8x equaling 12y. And then the other equation is going to be 1 plus 5 over 9 y equaling negative 7 over 18 x. You scared yet? Because I am. I don't know what the hell is this. Well, no, anyway, it doesn't matter. I should have done it on the paper so you could see my face. Alright, look. Choose the variable that you want to eliminate. Okay? Oh wait, you cannot choose. First of all, they're not in standard form. So let's put them in standard form. So look, all I gotta do is move this negative 8x to the other side. So I would get 12y, sorry. So I would get 8x, okay, plus 12y equaling, I did not do anything to this negative 24, so negative 24. Okay? Look, all I did was move this over here to the other side. So, and I put them in order. X first and then y. This one, I am going to actually take this one and I'm going to put it on the other side. I'm going to take this one and I'm going to put it over here. Or, you know what? Let's just move this over here. Let's just move it over there. So then, you're going to end up with these two terms together. So you're going to have negative 7 over 18 x, okay, minus, because I put it on the other side, minus 5 over 9y equaling to 1. Okay, all I did was put this one over here and then rearrange the equation so it looks like it's in standard form. All right, but that's the least of my worries. Like, how am I gonna do this? Well, choose what do you want to eliminate. What do you want to eliminate? If I want to eliminate, there are two ways in which I can do this, I think. I'm gonna show you what I'm gonna do. I'm gonna get rid of all these denominators. So bear with me. Okay, you might want to show this work somewhere else, or you know what? No. Take this equation and let's multiply by a common denominator. The common denominator here, okay? The common denominator here is 18. You already know how to do common denominator. All right. So this equation, when I multiply by 18, this 18 cancels with this 18, so therefore that leaves you with negative 7x. 18 times 5, I don't know what it is, but I know that 18 divided by 9 is 2. Times 5 is 10. Oh, okay. So minus 10y equaling 18 times 1 is 18. So this is my new equation, okay? These equations are equivalent. Look, what I did to one side, I did to the other. So this equation and this equation are the same. Just like if you have 1/2 and you turn it into 8 over 16. This is still 1/2, okay? Got it. All right, then now I'm gonna rewrite my two new equations because that was crazy. So I have I have 8x plus 12y equaling negative 24, and I have negative 7x minus 10y equaling 18. Okay, we're dealing with this system of equations. Okay, so now we choose what we want to eliminate. Now it's easier. Well, if I try to eliminate the x, I'm gonna end, this is a prime number, so I'm gonna end up multiplying by each other, and this is gonna be like 56. That's too much. How about 10 and 12? Where do they meet on the times tables? At 60. And how do I get that? At 60, let me see, 24. Man, why did they meet at 60? Okay, fine. 10 times 6 is 60, and 12 times 5 is 60. So, sure. Now I need to make them opposites. Well, they're already opposite signs, so I really don't have to multiply by sign numbers. So I'm going to multiply the top by 5 and the bottom by 6. Well, still better than multiplying this by 8 and this by 7. So, all right. So I'm going to multiply. Let's see what I get. 5 times 8 is 40, so 40x. 5 times 12 is 60, so plus 60y equaling. Okay, now I don't know what 24 times 5 is. It's 120. So negative 120. And now the bottom one. The bottom one becomes negative 42 x negative 60 y. And what is 18 times 6? That's 108. Okay. Woo. Now we eliminate. So then 40 minus 42 is negative 2x. 120 minus 108, or 108 minus 120. Okay. It's negative 12, right? Divide by negative 2, and x turns into positive 6. Okay, then you want to find out what the value of the y is. Sure. So get this 6 and substitute into one of the original equations. Yes, these were the original equations. Definitely you can always substitute there. My suggestion is substitute into these two original equations because these are equivalent. Okay, relax. Alright, so let's do it. So I'm going to substitute on the top one. So let's see. 8x plus 12y equals negative 24. So 8 times 6 plus 12y equals negative 24. 8 times 8 is 48 plus 12y equals negative 24. Okay, subtract 48 from both sides, and what do you get? 60. Okay, so 12y equals negative 60. Divide by 12, and y is equal to 5. Wait. Let's see now. Did I make a mistake? Okay, so let us think about this. Hold on a second. Why is 5? Where did I make the mistake? Let me go back. So 4 times 8, okay, that's 48. Subtract 48 from both sides. Oh my God, negative 24 minus 48 is negative 72. Oh, beker. Qué bruto, pero qué bueno que no. 72. So then when we divide by 12 on both sides, this becomes negative 6. Making my solution, okay, 6 for x and negative 6 for y. Okay, good. That's the point of intersection. Alrighty, so I'm going to take a little break, and then when I come back, we're going to do this substitution method. So now we're going to do the substitution method. At least one of the equations must be solved for either variable. If it's an x and a y, then either for x or for y. If it's a and b, then either for a or for b. So let's have our first example of solving system of equations by substitution. Let's have an easy one. So let's have okay, it was twist. So this is what we have. y equals 4x minus 9 and y equals x minus 3. So this is how it goes. You solve one of the equations. So what is y? Y is 4x minus 9. So when I say y, you say 4x minus 9. Why? 4x minus 9. Very good. So if I say 4x minus 9, what am I saying? I'm saying y. You understand what I'm saying? So then whenever you see y, you're going to think of 4x minus 9. So then you know what? Oh, wait. Let me say it again. Y. And you say 4x minus 9. So, good. Y. 4x minus 9. So you're going to take this y, okay, and you're going to replace it into the other equations y. That's basically the substitution method. All right then. So now, let us substitute. So what is y again? Instead of saying x minus 3, you're going to say 4x minus 9. So look, 4x minus 9y equals, and then x minus 3. In other words, you're setting both equations equal to each other. That's basically what it is. All right, let's solve for x. So distributive property, no. Fractions, no. Like terms on the same side, no. Variables on both sides, yes. So subtract x from both sides. Now 4x minus 1x is 3x. Bring down the minus 9. Cancel this out. That's 93. Alright. Now we have additive inverse. So we're going to use the additive inverse of negative 9, which is positive 9. Or as you were told, just add 9 to both sides. Negative 3 plus 9 is 6. Divide by 3 on both sides and you get x equaling 2. And now to find the y, okay, you have x, now you find the y. You just substitute. So take the value of x and substitute into either of the original equations. This is the easiest one. So I want to copy the equation y equal x minus 3. And now I'm going to substitute. So y equals, what is x? 2. 2 minus 3, and y becomes negative 1, making my solution, okay, 2 for x and negative 1 for y. Now please, I gotta tell you something that has tricked millions of students. If on the regents they give you the problem like that and they tell you, okay, which of the following choices is the correct response, and they show you 2, negative 1, then good. But if they show you negative 1 comma 2, those are not the values. Remember, x has to be 2, not negative 1, and y has to be negative 1, not x. So be careful if they switch the coordinates, okay? Because 2 comma negative 1 is not the same thing as negative 1 comma 2. If you were to grab those points, you'll see that they are not on the same position. All right. So this is one of the problems. You were lucky that they were both solved for y. Now let's do one where the equations are not solved for y. All right. So for example, 4x plus 2y. Okay. 4x plus 2y equal 10. And x minus y equals 13. All right. So how to proceed about it? Well, listen. Remember, at least one of the variables, at least one of the equations must be solved for either variable. So it's your choice. People usually solve for y. Okay. You could solve for x if you want to. It really doesn't matter. All right, let us solve for y. I think that the bottom equation is easier to solve for y, so that's the one I'm going to use. So all I'm going to do is I'm going to take this negative y and put it over here as positive, and I'm going to take this 13 and I'm going to put it here as negative. So positive y equals, I didn't change nothing on the x. All I did was switch the 13 over here, so it's x minus 13, okay? And since I swap the y over here and this over here, then you get x minus 13 equals to positive y. I hope you understood that. If not, then solve for y. Subtract x on both sides and then multiply by -1 so the y becomes positive. Doesn't matter. Okay. So now I have my two new equations. All right. The other equation that I have is 4x plus 2y equal 10. Listen, you don't need both equations to be solved for either x or y. You need just one of them. Okay? You need to have one of them so you could call them by name. If you solve both of them for y, you could just graph them. But anyways, so y is x minus 13. Wherever I see y, I'm gonna think of x minus 13. So take this y, which is x minus 13, and look, put it inside this other y. Now you get in the hang of it, right? Okay. So now what do I write? 4x plus 2 times y, which is x minus 13. Okay? Equals 10. Okay. So now we see we don't have a y anymore. We just have x's, and now we're going to solve the equation for x. So what are the golden rules? Well, let's see. Do I have any distributive property? Yes. So let's use it. 2 times x is 2x. 2 times negative 13 is negative 26. Okay. And now, we have fractions? No. Do we have like terms on the same side? Yes. Look, 4x and 2x. So this becomes 6x minus 26 equaling 10. Now, do we have variables on both sides? No. Additive inverse? Yes. What's adding or subtracting? The negative 26. So I'm gonna use positive 26. Alright, cancels out, and then 10 plus 26 is 36. Divide by 6 on both sides, and x is 6. To find your y value, you substitute this into the original equations. So, which one should I do? Yeah, let me do the bottom. The bottom looks nice. Also, you could do this one. I'm sorry. You could do the bottom here, or you could actually use this one, which is the equivalent of this. Right? But they say the original equation. So fine, let's use the original equation. X minus y equal 13. X minus y equal 13. X is 6, so 6 minus y equals 13. And you could subtract 6 on both sides. And you get negative y equals 13 minus 6 is 7. But then again, you cannot have a negative y as an answer, so you have to multiply by negative 1. So y equals negative 7. Making your order pair 6 comma negative 7, not negative 7 comma 6. Solution. Alright, so remember, the solution to a system of equations is the point where the two lines, the two curves as the calculator calls it, intersect. The point where the two lines have the same order pair. The point where two things are exactly the same. Okay? Cool then. So now, I'll do one more problem. Or actually, as a matter of fact, nope, you are going to do the next problem. Okay, so this is what I want you to do. X plus 7y equals 0. And then the other one is 2x minus 8y equals 22. All right, do it. Okay, so what do we got? Remember, you got to do it, you pause it, whatever. So you're supposed to get, if you get this, then you are correct. If not, then you're going to have to go back and revisit the method. Remember, at least one of the equations must be solved for a variable. Alright, I want you to try this other one, okay? And I need to change the color of my marker. Alright, try this one. Good. Now your solution should be 0, -5. Now look at something. Y is -5. So basically you already have one of the solutions. So all you have to do is replace this over here and you get your x and boom, 0. Ha ha ha. Alright, cool then. So now you know all three methods of solving system of linear equations. Okay. Then we go in the future, we're gonna see system of linear and quadratics. Right now, chillax. Alright, see you on the next episode.